Hey everyone, this is Anirudh from Edureka. In this session, let me walk you through a few advanced concepts that is widely used in Python and that you can make use of really well. Well guys, this session is intended to be useful for anyone who's considering to kickstart their learning about Python in detail and needs some insight about how Python is used for advanced use cases and applications which are eventually built using the language. The focus is on approaching the language in the easiest way possible and to find out what it has to offer for the community and all of the learning enthusiasts out here. So guys, let's begin by checking out the agenda for the session. We'll start with Introduction to Advanced Python, and later we'll be getting started with Python and the shell. Followed by that, we'll be looking at key concepts in Python. And lastly, we'll be looking at how easy it is to code with Python, where we'll take a programming approach and learn each of these concepts through code directly, guys. So now that that's clear, let's begin by checking out what advanced Python actually is. We already know that Python is a programming language, right? Well, to be more specific, Python is a really powerful, high-level, object-oriented language. Which was created by a person called as Guido van Rossum. Guys, Python is and always has been easy to learn and master in my opinion. It is very beginner friendly and the syntax is extremely simple to read and follow through, guys. This definitely makes us all happy, and surely yes, Python has millions of happy learners across the globe. And I can't begin to tell you how fun it is to actually work with Python. So let's get started then. I'm sure you guys are curious about what advanced Python is all about, right? Well, it is really simple, guys. Python can be used for a variety of purposes, and this is exactly what we mean by making use of Python for advanced purposes. The more complex your problem, the more advanced solution feels like the best fit using Python. Well, to simplify that last statement, what I actually meant is that Python can be put to use all the way from simple applications till you achieve artificial intelligence. Well, check out some of the below concepts that you can use. We have system programming, we have graph theory, we have mathematics, computer science, numerical computations, and databases. Well, system-focused programming is better than calling it system programming, to be honest. Well, system programming, or systems programming as it is also called, often refers to the activity of programming a system software, guys. Simple as that. Well, this deals with the programs which are often part of your operating system, right? Again, fairly straightforward. Well, our topics in this session will deal with pipes, threads, and forks, and all of these guys. We'll be using Python script throughout, so make sure you stay tuned till the end. Well, graph theory involves modules like PyGraphs and NetworkX, and all of these are used to implement a graph class with essential functionalities for graph creation, manipulation, and calculation. And in mathematics, you can check out how you can work on polynomials and how easily and beautifully a class is present for the creation and manipulation of polynomial functions that can be written in Python. Well guys, the advanced concepts with computer science definitely involves concepts like finite state machines or Turing machines and even text classification with naive bias and all the concepts like this, right? Well, with numerical computation, if you want to get fast and efficient results with arrays and matrices or so, the NumPy module of Python is definitely the right tool collection for you guys, right? And the module matplotlib is all you will require to plot and depict your data. Also, an introduction into linear combination is actually a good start for this advanced concept. Well, databases is pretty simple and straightforward. It is basically how Python is used with database management software like MySQL or anything else. Well, now that we know what can be done with advanced Python, let's take a look at system programming using Python now. Guys, like all the other modules, the system module has to be imported with the import statement. It is pretty much simple. It is as simple as import sys. So guys, I'm going to keep it short and I'm going to call it sys. So whenever I say sys, it means that I'll be implementing this module, right? So basically the sys module provides information about constants, functions, and methods of all of the Python interpreters present in the machine, guys. Well, we can actually use directory of system to give us a summary of all the available constants, functions, and methods and all of that as well. Another possibility is to actually use the help function in case you don't know anything about the module. Well, using help of sys will actually provide you really valuable information, guys. And the current version of Python can be accessed as well using this small piece of code that you can see here. So sys.version will actually give you the output, which is the actual version number, which is 2.6.5 here, as you can see. Pretty simple, right? So again, lots of scripts will need access to the arguments passed to the script when the script was started, right? So we need something called as argv. So what is argv, guys? Well, to be precise, we call it sys.argv. Well, v stands for variable and arg is actually argument. Well, it is basically a list which contains all of the command line arguments which is passed to the script, right? So the first item of this list contains the name of the script itself. and the arguments follow the script name. So check out the script, right? So we have a really simple script which iterates over the sys.argv list, and let's say we save this as arguments.py or anything you want, and we can later call it and we'll actually get the following output. So all we do is we import the sys module and we print the list using sys.argv, or you can actually do it via loop as well. So we have a for loop here and we have considered the iteration until the length actually maxes out. And if I is 0, print the default system argument, else print the argument whatever the user has actually input. Check out the output on the right side. It's pretty much simple, right? So Python arguments.py is the name of the file, argv1 and argv2 are the arguments that we have passed to argv. And function name, it says arguments.py because that is the name of the program. And then the first argument is arg1, second argument is arg2. Here I could give anything, right? So instead of arg1, I could give it as Edureka, and instead of arg2, I could have given it as Anirudh. And in this particular example, it won't make sense, right? So all we're trying to do is we've printed and we're not using those arguments anywhere else. So next up, Python's interactive mode is one of the things which makes Python really special among all of the other languages like Perl or Java as well. Guys, it is enough to write an expression over the command line to get back a meaningful output in really simple terms. However, some users might prefer a different output behavior. Well, to change the way the interpreter actually prints interactively using the entered expressions, we will actually have to rebind the sys.displayHook to a callable object. Well, let me just repeat that for you guys. So basically we have the interpreter which actually prints interactive entered expressions, right? So we'll actually need to rebind the sys.displayHook to a callable object. We will demonstrate this in the following interactive example. Check it out. We can see from this example that the standard behavior of the print function will not be changed. So importing sys, we are putting a value of 2x, right? So x equal to 42. Again, we're defining my display and we're printing out and again printing x. Here we're using the display hook, right? So sys.displayHook is equal to my underscore display and x. Well, the print function actually remains the same, as you can check it out, right? So this is how we can actually change the output behavior, but without changing the behavior of the function. And also, every serious user of Linux or Unix operating system knows the standard streams, right? So it is input stream, standard output stream, and the standard error streams. Well, guys, they're also known as pipes. They're commonly abbreviated as stdin, stdout, and stderr. So the standard input, stdin, right? So it is normally connected to the keyboard, and while the standard error and the output actually go to the terminal or the window in which you're working. So standard input accepts something from the keyboard, pretty straightforward. Standard output and standard error actually display some error or a message for you, right? So it obviously goes to the terminal or the window in which you're working. These streams can be accessed from Python via the objects of the sys module with the same names. Basically, we'll be using sys.stdin, sys.stdout, and sys.stderr. Pretty simple, right? Well, this next example actually illustrates the use of standard data streams. So we have imported sys and we're printing going via stdout. Then we have stdout.write. It says another way to do it. Again, print it. Then we have x is equal to raw underscore input. It says read value via stdin. Again, the value read is 42. As soon as we print x becomes 42. X is printed. Next, type in the value. We're actually going to type in a value where we're using stdin.readline to actually get the input. So type in value. As soon as it says 42, 42 is printed. Instead of 42, I could have put it as Anirudh. I could have put it as Edureka or anything else as well. And that's the same message that would be printed. Pretty simple, right? So next up, we have something called as redirections. Let's check it out. Guys, there is hardly any user of a Linux or a Unix shell, right? So example, Bourne shell or the bash shell who hasn't used any input or output redirections. It is not exaggerated to say that a useful work is not possible without redirections, if you follow me. The standard output, which is stdout again, can be redirected into a file so that we can actually process this file later and use it with another program. The same is possible with the standard error stream. We can redirect it to a file as well. So we can redirect both stderr and stdout into the same file or the separate files as well. So the following code should actually be self-explanatory by now. But nevertheless, here are some of the explanations that I can put out for you guys, right? So the first statement uses the regular standard output stdout. So the text is coming through stdout, will be printed into the terminal, and from which the script has actually been called. In the next line, we are actually storing the standard output channel in the variable save_stdout. So that we are capable of restoring the original state at a later point in the script. After this, we open a file which is called as test.txt for writing. After the statement sys.stdout equal to fh, all of the print statements will directly print into this particular file. What's the file? Test.txt. The original condition is restored with sys.stdout equal to save_stdout. So guys, your fh is actually file handling. Pretty much simple, right? Check out the following example. Here I actually show on how you can redirect the standard errors into a particular file. It's almost simple, and all we're doing is we're using sys.stderr to actually save the error state of that particular case. Simple, right? So next, let us check out some interesting variables and constants that are present in the sys module. Guys, you have many here, and let me try to quickly walk you through a few. So we have byte order, we have executable, we have maxent, modules, path, platform, and many more, right? So what is byte order? Well, byte order is basically an indicator of the native byte order, guys. Simple as that. So what's executable? Well, a string containing the name of the executable binary. Well, what I mean is the path and the executable file name for that particular Python interpreter. Well, maxent, guys, this attribute contains the largest positive integer which is supported by Python's regular integer type. And modules, well, the value of the sys.modules is actually a dictionary mapping. So it maps the names of the modules to the modules which have already been located. And this can be manipulated, guys. Well, consider an example, right? You can enforce the reloading of modules as well. That is a really good fit for this case. And next we have path. Well, path contains a search path, guys, where Python is actually looking for all of the modules that are present. And lastly, platform. Can you take a guess? Well, guys, again, name of the platform on which Python is actually running on, right? So Linux 2 for Linux and Win32 for Windows. Simple. Well, now that we saw the system programming, next we'll actually look at Python and the shell, and let us dive a little bit more into system programming. So guys, shell is a term which is often misunderstood, right? So it is used majorly, but it is definitely misunderstood in my opinion. So let's say like the shell of an egg or a hen or a Python snake or a mussel or anything. The shell in computer science is generally seen as a piece of software that provides an interface for the user to use some operating system or a software. So guys, the shell can actually be an interface between the operating system and the services of the kernel of this particular operating system. But a web browser or a program functioning as an email client can be seen as shell as well. Well, understanding this, it is obvious that the shell can be of two types, right? So it can either be command line interface, which we call it as CLI, or a graphical user interface, which is obviously GUI. But guys, in most cases, the term shell is used as a synonym for a command line interface, which is CLI again. The best known and the most used often shells in Unix and Linux are the Bourne shell, C shell, or the Bash shell. The Bourne shell, which is abbreviated by SH, was actually modeled after the Multics shell, and this was actually the first Unix shell, guys. So this is something which is important and interesting, and you could note this down. And most operating system shells can be used both in interactive mode and in batch mode as well. By batch mode, I obviously mean the COI mode. So pretty simple, right? So next up, systems programming. Again, let me quickly come back to system programming again, right? So system programming basically stands for the activity of a programming system components or of the system software. So giving the user the ability to actually develop these and work on other softwares when you're present in a software environment, right? So the system programming actually provides software or services to the computer hardware, while application programming produces software which provides tools or services to the user. Again, this is important, so let me repeat, guys. System programming actually provides services to computer hardware, while application programming produces tools or services which the user uses. Simple, right? So system-focused programming, as I'll call it, is actually made possible with the aid of the sys and the OS module. Guys, this serves as an abstraction layer between the application, which is the Python script or the program, and the operating system. You getting it, right? So basically, again, operating system is anything between Linux or Windows or anything. By means of the abstraction layer, it is actually possible to implement independent applications in Python, even if they access operating specific functionalities, guys. So well, in my opinion, Python is well suited for system programming or even platform independent system programming as well. So the general advantages of Python are valid in system focused programming here too. So it is simple and clear, it is well structured and definitely highly flexible, guys. So next up, we have the OS module that I discussed. Guys, the OS module is the most important module for interacting with the operating system. The OS module basically allows platform independent programming by providing abstract methods. Well, nevertheless, it is also possible by using the system function and the exec star function. And these families include system independent program parts as well. Guys, the OS module provides various methods like accessing the file stream, which is again a very important thing. Well, it is not possible in Python to read a character without having to type the return key as well. On the other hand, it is extremely easy to do this on the bash shell. So the bash command actually reads n-1 wait keys for any key which is inputted by the user. If you actually import OS, It's really easy to write a script providing getch by using the os.system function and the bash shell. Guys, getch actually waits just for one character to be typed without a return. So check this out. So the script here on the left actually works only on Linux. Under Windows, you actually have to import the module msvcrt. Well, principally we have to import both getch from this module as well. And this on the right side you see is actually the solution for the Windows. So we are actually importing msvcrt and importing getch as well. Simple, right? So next, so guys, the script I have for you actually implements an independent solution to our problem. Well, what independency do you ask? Can you guess? Well, definitely it is actually platform independency, guys. Well, here actually the script has a little bit of problem, right? So can you take a guess? Well, you can't actually use the getch function if you're interested in the key which has been typed, because os.system doesn't return the result of any of the called shell commands, guys. So now that is actually a little problem, but then again, it's good enough for a simple level, right? So what I want you guys to focus at this point of time is actually how you can write code like this, right? And here's a quick note for you guys, right? So head to the comment section and let me know how you think you can fix this, guys. I will actually discuss this by the end of the video, but head to the comment section and let me know on how you can do this, okay? And well, now that we're actually done with that, we can look at forking in Python next. So a tree is actually an example for forking, guys. Long before biologists actually started their research on cloning or something, computer scientists had actually had a successful history of cloning. They had cloned processes, even though they didn't call it cloning exactly, but they called it forking. Are you getting the picture here? Forking is the same as cloning. Well, forking is one of the most important aspects of Unix and Linux, guys. When a process forks, it actually creates a copy of itself. Well, more generally, a fork is actually in a multi-threading environment, which means that a thread of execution is duplicated, creating a child thread from the parent thread. They are identical, but definitely can be told apart. How can they be told apart? Well, definitely the process ID, guys. I'm pretty sure most of you would have guessed it by now. So the fork operation creates a separate address space for the child and the parent. So the child process has an exact copy of all of the memory of the parent process. The execution of the parent and the child process is definitely independent of each other, right? So in computer science, the term fork actually stands for at least two different aspects here. Follow with me. The first one is definitely cloning of a process, which is roughly as described above. And in software engineering, a project fork happens when the developers take a legal copy of the source code from one software package and start independent development on it. Well, this way, starting on a distinct piece of software as well, right? Well, the system function called fork actually creates a copy of the process, which it has been called for. So this copy actually runs as a child process of the calling process, guys. The child process gets the data and the code of the parent process. The child process receives a process number, which is actually PID, or we can actually call it process ID as well. So of its own from the operating system. So the child process runs as an independent instance. This means that independent of a parent process as well. With the return value of fork, we can actually decide in which process we are. 0 means that we are actually in the child process, while 1, which is a positive return value, means that we are in the parent process. Well, it might not be 1 in all of the cases, but it can be any positive return value, guys. A negative return value basically means that an error has occurred while you're trying to fork. And to be able to fork the process, we need to import the OS module in Python. Well, check out this Python 3 example I have for you guys. Here I'm showing a parent process which actually forks every time the user types in the letter C when prompted. Both the child process and the parent process continue after the if new PID equal to 0 line, right? So this particular line. So the value of the new PID is greater than 0 in the parent process and 0 in the child process. Well, the exit statement os.exit of 0 of the child function is definitely a necessity, guys. So make sure you don't forget that. If you don't do this, the child process would actually return into the parent process. I mean, into the input statement in this particular case. So that doesn't make sense, right? Again, all of this code is really simple, and I suggest you to pause the video, take a good look at the code, and you would understand every single line of it, guys. So far, we have covered functions in our examples, which are defined in the same script file, right? Forks are actually often used to start independent programs. To do this, we need to use the exec star functions, guys. So they execute a new program by replacing the current process of that program. So they execute a new program by replacing the current progress of this program. They do not return to the program which has called them. Are you getting it? So they even receive the same process ID as the calling process again. So these are the different forms of exec functions as shown. There are a variety of purposes for each of these functions, which I will cover in another tutorial soon. So now that we're done with exec functions, let us quickly look at threads. Well, we look at how we can work with threads in Python, and it is pretty much simple, guys. So what is a thread? Well, a thread, or also called as a thread of execution in many cases, right? So it is actually defined in computer science as the smallest unit which can be scheduled in any operating system. Well, threads are normally created by a fork statement of a computer script or a program in general in two or more parallel tasks. These can be implemented on a single processor by multitasking as well. Threads are usually contained in processes. More than one thread can exist within the same process, guys. So this is important. I want you guys to note this. So more than one thread can exist within the same process, as I say again. These threads share the memory and the state of process as well. And in other words, they actually share the code or instructions and the value of their variables as well. So guys, there are two kinds of threads. We have kernel threads and user threads. Well, kernel threads are a part of the operating system, while user space threads are not implemented inside the kernel. Well, in a certain way, the user space threads can be seen as an extension of the function concept of the programming language again. Well, so a user space thread is similar to a function or a procedure call. But there are differences to regular functions, especially in the return behavior, guys. So this is again another important thing. And well, every process needs to have at least one thread, right? So the process itself is a thread. A process can start multiple threads actually. The operating system executes these threads in parallel processes, guys. Parallel, remember that. And on a single processor machine, this parallelism is achieved by something called as thread scheduling or time slicing. So what are the advantages of threading, guys? Well, multi-threaded programs can run faster on computer systems with multiple CPUs because these threads can be executed truly concurrently, right? So they can be truly run parallelly, guys. So they can be run parallelly in a true form. And a program can remain responsive to the input as well. Well, this is true both on single and on multiple CPU as well. Well, threads of a process can share the memory of global variables too. If a global variable has changed in one thread, so this change is actually valid for all the threads. Well, a thread can have local variables as well, guys. Check out the image on your screen, right? And the handling of the threads is really simpler than handling of processes for any operating system. That's why they're sometimes called as LWPs. Can you guys take a quick guess on what LWP is? Well, it is actually lightweight process. So there are two modules which support the use of Python in threads, thread and threading. Well, guys, you need to know that the thread module has been considered as deprecated for quite a long time now. Well, users have been encouraged to use the threading module instead of the thread module. So in Python 3, the module thread is no longer available. But actually, this isn't really true. It has actually been renamed to _thread for backward incompatibilities in Python 3. So the module thread treats a thread as a function, while the module threading implements in an object-oriented way. So here every thread corresponds to one particular object, guys. And it is possible to execute functions in a separate thread with the module thread as well. So to do this, we'll actually use the function thread.start_new_thread. And the parameters are actually functions and arguments to this. Well, this method actually starts a new thread and returns its identifier. The thread executes the function, well, in our particular case, we call it function, with the argument list, guys. So an argument list is actually a list or a tuple. And guys, there is an optional argument which is called as 𝐾𝐻 as well. Well, what does this do? Well, this actually specifies a dictionary of the keyword arguments. When the function returns, the thread silently exits. When the function terminates with an unhandled exception, a stack trace is printed and then the thread exits, guys. But this will allow the other threads to continue. So again, take a look at your screen, right? So here is the example for a thread in Python. So the raw_input in the example is very much necessary. Why? Because otherwise all the threads would be exited at the same time if the main program finishes. Raw_input waits until something is actually being typed in by the user. So pretty simple, right? So as soon as you type something, it actually quits. Well, again, take a quick look at the code. So the code on your screen actually doesn't work the way we might expect it to work. Can you guess what is wrong? Well, the problem is that in the final while loop will actually be reached even before one of the threads could be implemented with the counter, guys. So in our case, the counter was num_threads, right? But there is another problem. The thread arises by assignments to num_thread. num underscore threads plus equal to 1 and num underscore threads minus equal to 1. These assignment statements are not atomic. So an atomic assignment statement actually consists of 3 actions. It starts with reading the value of the num underscore thread, and then we have a new int instance which can be incremented or decremented by 1. And then the new value has to be assigned to num underscore threads. Well, errors like this actually happen in the case of increment as well. So the first thread reads the variable num underscore threads, which still has the value 0. After having read the value, the thread is put to sleep by the operating system, correct? Now it is a second thread's turn. It also reads the value of the variable num underscore threads, which is again still 0. Because if the first thread has been put to sleep too early, again before it has actually been given the chance to increment its value by 1. And now the second thread has been put to sleep. And now it's again the third thread's run, which again reads as 0, but the counter should have been 2 by now. Each of these threads assign now the value 1 to the counter. Similarly, the problem occurs with the decrement operation as well. Well, not to worry, problems of this kind can be solved by defining critical sections with lock objects, guys. So these sections will be treated automatically. Well, during the execution of such a section, a thread will not be interrupted or put to sleep. The method thread.allocate_lock is actually used to create a new lock object. Lock_object is equal to thread.allocate_lock. Getting it right? And the beginning of a critical section is actually tagged with lock_object.acquire and the end with lock_object.release. So we have acquire, lock, and release. So the solution looks something like this on your screen, guys. Check it out. Pretty simple, right? So next, we want to introduce a threading module with an example. So the thread example doesn't do a lot, right? So essentially, it just sleeps for 5 seconds and print the message. Method of operation of the threading.thread class is actually very interesting. So the class threading.thread has the method which is called start, which can actually start a thread. Simple. So it triggers off the method run, which again has to be overloaded again. Once overloaded, the join method makes sure that the main program waits until all of the threads have been terminated. So in the previous script actually returns the following output. Thread 0 sleeps for 5 seconds, 1 for 5, and again as soon as thread 9 sleeps for 5 seconds, thread 1 wakes up. Thread 0 wakes up, 3, 2, and in the order, right? So here's a quick look at the code again so you can check it out. I really recommend you actually pause the video at this point of time, type in the code on your own, and change these statements to actually see how they work. Well, I hope you guys are practicing the code at this point of time, because next up, I have for you guys something really simple and interesting. So let me quickly introduce you to the last concept for the session, which is pipes. Guys, it is very interesting as I've mentioned, so let's begin. So what are pipes, guys? Well, Unix or Linux without pipes are unthinkable. Well, at least pipelines, because they are an important part of Unix and the Linux application and architecture, guys. Well, small elements are put together by using pipes. Processes are chained together by their standard streams. So that is what I actually mean by that, is the output of one process is actually used as the input of another process. Well, to chain processes like these, we actually call anonymous pipes. So the concept of pipes and pipelines were actually introduced by a person called as Douglas McElroy. Again, one of the authors of the early command shells. Only after he noticed that so much time they were actually processing the output of one program as an input to the other. Ken Thompson added the concept of pipes to the Unix operating system way back in 1973. Pipelines have been later ported to other operating systems such as DOS, OS2, and Microsoft Windows as well. And generally, there are actually two kinds of pipes: anonymous pipes and named pipes, guys. Anonymous pipes exist solely within the processes, and they're actually used in combination with forks. We'll be checking out name pipes in the next section. Well, now is something really interesting. So let us consider one classic example, guys. So we have something called as 99 bottles of beer. What do I mean? Well, 99 bottles of beer is a traditional song in the United States and Canada. Well, the song is derived from the English song, which is 10 green bottles. The song consists of 100 verses, which are again very familiar. Well, just the number of bottle varies, guys. So only one, right? So the 100th verse is actually slightly different. This song is often sung on long trips because it is actually easy to memorize and it can take a long time to sing and it's fun. So here are the lyrics of the song. 99 bottles of beer on the wall, 99 bottles of beer. Take one down, pass it around. 99 bottles of beer, 98 bottles of beer on the wall. Pretty catchy, right? So the next verse is actually the same, but it starts with 98 bottles of beer. So the general rule is that each verse has one bottle less until there is none left. The song normally ends here, but we want to implement the infinite version of this song with an additional verse, right? So we want no more bottles of beer on the wall, no more bottles of beer. Go to the store and buy some more, 99 bottles of beer on the wall. This song has actually been implemented in all of the conceivable computer languages known to man, to be honest, and it is this famous, guys. Well, let us actually quickly look at some code to understand this. So again, whatever I've explained is exactly what is going on in this particular piece of code. So the output looks something like this, right? So 99 bottles of beer on the wall, 99 bottles of beer. Take one down, pass it around, 98 bottles of beer on the wall. Pretty simple, right? So it keeps decreasing. So guys, I just quickly scroll down to the verse 99. Here again, one bottle of beer on the wall, one bottle of beer. Take one down, pass it around, 0 bottles of beer on the wall. So verse 100 is where it changes. So no more bottles of beer on the wall, no more bottles of beer. Go to the store, buy some more, 99 bottles of beer on the wall. Again, verse 101, it starts with 99 and keeps going on, right? So I hope you actually got the point. It keeps on going until it actually hits an exception, guys. Well, in this particular case, I'm actually using an online compiler for Python. So there has to be a limit to that, right? So it keeps going, it keeps going. Well, at one point of time, it is actually going to end. And again, in this particular case, it is the 509th time, guys. So there are actually 509 times our verse actually ran. So each of it is 100, right? So it actually repeated 5 times. So now that this is done, let me quickly go back to the program so we can check out what's next. So guys, the last concept for today is named pipes. Well, under Unix as well as Linux, it is actually possible to create pipes which are implemented as files. These pipes are actually called as named pipes or sometimes FIFOs. What is a FIFO? First in, first out. So a process reads from and writes to such a pipe where as if it were a regular file. Sometimes more than one process writes to a pipe, but only one process can read from it at a time. Well, there is so much more we can actually do with pipes on the whole. I've kept it short and in a simple level so that you all can understand the code and start better and faster with it, right? Well, let me quickly conclude this session for you guys. We started out with Introduction to Advanced Python. We looked at why Advanced Python was needed. We later checked out what various simple components of system programming are as well. And I hope the code first approach definitely helped you guys to understand the code better and faster. So guys, it is at this point of time I'd like to tell you that I have curated an in-depth video for Python which is actually meant for beginners. I'm getting some really good feedback on that, so I want you guys to check it out. And let me know how you feel about it. We also have in-depth videos for majority of the advanced Python concepts and so much more. I will leave links in the description box below, so make sure you check it all out. So that is it for this small session, guys. I hope you took away some real good points from here and that this kickstarted your Python learning to its max. So thank you guys, you know what to do. If you have any query, leave a comment and subscribe to our channel for more information on the latest technologies and all of the courses offered.